This is the 6th video in the Beginner Robotics Virtual Summer Camp series. Today, we're going to be talking about the different types of maneuvering that you can do with the EV3 robot. First, let's start with the simplest action of all, moving straight. By moving straight, you are essentially telling the robot to go forward or backwards. So to move straight, you would use a move steering block from the green programming tab section. To activate it, you would drag it into the programming canvas until it connects with the green play button or previous blocks you have placed in the programming area. The move steering block has 6 properties. The first one is the operation mode selector. You can select between off, on for seconds, on for degrees, and on for rotations. Second property is a motor selector. You must select which motors you would like to control with this block. Many teams prefer to keep their drive motors as B and C. Next, the straight steering turn steering property. This one controls whether the robot will go straight or whether it will make a turn of a varying angle. Next, the speed property. This sets the speed of the motors of the robot. Next, the distance property. This sets the amount of rotations that the motors of the robot should rotate before the block ends. The last property is the brake coast property. This sets whether the robot should just coast when it reaches the end of the block or whether it should try to actively stop. There are 2 types of power in the first LEGO robot, negative power and positive power. Figure 1 illustrates positive power, which means that when power is applied to the motor in the positive direction, this means that the motor moves forward. Figure 2 illustrates negative power, which means that when power is applied to the motor in the negative direction, this means that the motor moves backwards. Here are some quick programming tips for programming with EV3 bricks. Firstly, your program can take time to perfect. You should expect to spend plenty of time perfecting dimensions like seconds, rotations, or degrees in your program. These things take time and patience to tune perfectly. Secondly, the wheel size of the robot wheels will affect the amount of rotations it takes the robot to reach something on the field, so keep that in mind when you are changing wheels on your robot. Lastly, the battery level of the EV3 brick can affect the power that the EV3 brick can give to the motors, meaning that if the battery is low, then the robot may feel sluggish and slow to respond. So if the robot is acting unusual, it is worth it to change out the battery before messing with the power in the program. A pivot turn is a turn in which the robot does not stay at the original horizontal line throughout the turn. Let's look at an example. Here's a horizontal line. As you can see, the robot is facing towards the right, and motor B is on the top. Now if you make a 180-degree pivot turn, only motor B moves. Motor C doesn't move at all. So the robot ends up off the horizontal line. And we can now see that the robot is facing towards the left, having completed its 180-degree turn, and motor B is on the bottom. So during a pivot turn, the robot ends up moving significantly in the direction of the turn. As the name suggests, the spin turn, unlike the pivot turn, lets the robot stay at the original line throughout the turn. Let's look at an example. Here's a horizontal line. As you can see, the robot is facing towards the right, and the motor B is on the top. Now if we make a 180-degree spin turn, both motor B and C move in opposite directions. So, because of this, the robot gets to stay on the same horizontal line, it just changes direction. So now that we've learned about the spin turn and the pivot turn, let's compare them. The spin turn is by far the most useful in tight areas where you don't have a lot of room to maneuver. But it is important to keep in mind that the spin turn is typically less accurate than the pivot turn since it is faster. In comparison, the pivot turn is much more accurate than the spin turn and can be used for precise turns since it is slower. But the pivot turn requires much more space to complete properly since only one motor moves. Now that we've covered the 2 types of turns, let's get into the actual turning. Like turning straight, we would use a move steering block from the green programming tab section. You would drag it to the programming canvas until it connects with the green play button or the previous blocks on the programming canvas. Since we're using the move steering block again, we don't need to go over all the properties, but we do need to change a couple. Firstly, the operation mode selector will be set to degrees this time instead of rotations or seconds, and the steering property will be set to a left or right turn. I set it to 50 for this example. Once you do this, you'll notice the distance properties change to degrees. This determines the sharpness of the turn. The rest of the properties can stay the same. Here's some quick programming tips for programming turns with EV3 bricks. If you set the degree of the turn to anything between -50 and 50, then the robot will make a pivot turn left or right. But if you set the degree to -100 or 100 degrees, then the robot will make a spin turn left or right. Lastly, setting the robot to turn 180 degrees on the EV3 Mindstorm software does not actually mean that the robot will turn 180 degrees. You need to use port view on the EV3 brick to measure the turn and then use that information to find the right amount of degrees. So, in conclusion, moving straight and turning are just some of the ways that you can control the EV3 robot using the EV3 Mindstorm software. Moving straight and turning using the EV3 robot is like moving straight and turning in a car. There are 2 types of turns, pivot turns and spin turns. They're both useful in different situations on the field. Lastly, make sure to remember that a turn is a pivot turn if you set the steering value to -50 or 50 degrees, and is a spin turn if you set the steering value to -100 or 100 degrees.